Hello, today I want to talk to you about transformations of quadratic functions. So if you remember from middle school, you did talk about transformations. You talked about reflections, which were flips on the coordinate plane. You talked about translations, which were slides on the coordinate plane, right? So what we're doing is we're looking at how we can transform a quadratic function from its original parent function to the new function. So when you think about how transformations work, parent function, so what does that invoke? It invokes that there is some place where you start. All babies start somewhere with their parent. And as they get older, things change and they move out. So think of the parent function as the baby who started with the parent, and then as they get older, the transformation is, what did that child do when they got older? So just to give you an idea, it's a very simple idea, but you can certainly use it with transformations. And what you will need to remember is these particular key ideas here. If you have a function and it adds, so notice it says x plus h, so that means that there is a movement on the x-axis. So the movement on the x-axis is always opposite of what you see. So when it says x plus, you're actually going to translate to the left, which means you're going to write minus a number. When it says x minus, it translates to the right. So you're going to write plus a number. Now here is the parent function plus k. So the translation is up. So you're going to write it exactly how you see it. So it'd be plus a number. And here we have the function translated down. It would be minus a number. And here we have reflections. So we have the reflection across the x-axis, and then we have the reflection across the y-axis. So here the whole entire function is reflected. Here just the x value is reflected. So let's go ahead and take a look at this. Find g of x, where g of x is the translation 7 units up of f of x equals x squared. So this f of x equals x squared is your parent function. And parent functions always go through 0, 0. So the vertex is always 0, 0 of a parent function. So now we're saying, okay, well, what happened? I want to translate this function 7 units up. So there's no left or right movement, so we're not going to do anything with that. We're simply going to write the new function. G of x is equal to the parent function, no movement, but it moves 7 units up. So I'm going to put plus 7 because it's exactly as it should be. Now, the next one, find g of x, where g of x is a translation 6 units left, meaning it's a movement on the x-axis. So I'm going to write x-axis movement. And it says write your answer in the form of a x minus h squared plus k. So remember, this is vertex form. So our new function is g of x, and it started out with the parent function x squared. Well, there was movement. It moved 6 units left. So when it says it moves 6 units left, let me see if I can pull this down so you can see. When it said it moves 6 units left, here we write the opposite sign. So we're going to write plus 6. And what kind of function is it? It's a quadratic function, so we need our squared out here. But there was no movement up or down, so we're going to put plus 0. Sometimes you'll see it written without the plus 0. Either way is fine. Here, the next one we have, the graph shows g of x, which is a translation of f of x. Write the function rule. So this time they're showing it to us as a graph instead of an equation form, but nothing changes. The first thing I want you to look at when you're doing this is, was there a left or right movement of the vertex? Did the vertex move? If the answer to that is no, I'm going to write this so you'll remember what to question yourself. Did the vertex move? The answer is no. So we don't need the parentheses part of the vertex form. We're only going to need the K part because it didn't move left or right. The vertex only moved down. So we would write our function as g of x is equal to x squared. So we're writing what type of function it is and what it did. It moved down 1, 2, 3. So x squared minus 3. And then we have this particular part where we see it. Now this one, it says find g of x, where g of x is a translation 3 units right. So what I know is I'm going to write it as a negative or subtraction, right? And it says 1 unit down, so that's minus 1. So this was minus 3. Write your answer in the form of a x minus h squared plus k. So y is equal to, and I'm not writing the a right now because it didn't tell us there was a stretch. So we can pretty much write it as x. It says right, so we know we've actually put minus 3 squared minus 1. And we're done. I believe it is your turn. So here is what you have. Go ahead, give it a try. I'll be right back. All right, so here are the answers to the now it's your turn. I want to give you a piece of advice when you're doing these, because sometimes, you know, when you're talking about movement on the x-axis, it can be a little bit interesting or challenging to think in opposite directions. But here's something that might help you. When you are writing the x movement, meaning the left or right movement on the x-axis, I want you to think about, what does this function have to do to get back to 0? So if I'm on the left side at -3, I would have to add 3 to get back to 0. So that's how you can think of this as well. Here it said 7 units right. So what would I have to do if I'm at 7? I would have to subtract 7 to get back to 0. So that's just a little bit, a tidbit that can maybe help you with, oh my gosh, you know, do I put plus or do I put minus? So hopefully that was helpful. This is the end of this video, but again, as always, if you have questions, please don't hesitate to ask.